In this video, FA2-2, we're going to talk about what a rational number is. So in class we talked about what a rational number was. And remember, by definition, a very basic definition of a rational number is when it can be a over b, which is any fraction, but b, it can never be 0. So in this situation, it can be any fraction, any number, positive or negative, as long as you could eventually, if you wanted to, write it as a fraction. So for example, the number 7, if I wanted to, could write it as 7 over 1, which is your a over b, and your b is not 0. 0.3, if I wanted to, I could write that as 3/10, which is a over b, and b is not 0. So that's what we're looking for with rational numbers. Rational numbers are numbers that repeat if they're decimals, and they terminate, because if they repeat, we can write them as a rational number, and if they stop or terminate, then we can write that as a rational number as well, and we'll show you that as well. So let's just get started, and we'll see where we get. So right off the bat, it asks which of these are rational numbers, and again, I'm going to let you do that on your own. Just look at the definitions, and you should be okay. Remember, what we're looking for is, for our targets are, can you identify rational numbers? Can you write rational numbers as a decimal? And can you write a rational numbers that's represented on a number line, which will be questions like number 10 and so on. So remember your targets when you're doing all these worksheets. So which ones of these are rational and which ones are irrational? So all I'm going to look for is any number that I can write as a fraction, a over b, and b is not 0, or a terminating decimal, or a repeating decimal. So this number repeats, however, all must repeat. So this one here would have to be an irrational number. H 1000 can be written as 1000 over 1, which is my a over b, and b is not 0, so this is rational. J, usually anything with a square root, a rule of thumb, unless it's a perfect square, it usually comes off as irrational. Now you can throw that into a calculator and see, but most likely that's going to be irrational. The rest you're going to need to go through and see. For example, that's a perfect square, so that one's probably rational. Just check it. Number 5. Identify equal rational numbers. Okay, so they're telling you these are all rational, which ones are equal. So all you're going to do is you're going to circle the ones that are equal, or make some kind of, denote it. So negative 2/3 and negative 2/3, those would be equal to each other. It doesn't really matter where the negative sign is. Value-wise, if I converted those to a decimal, I'd get negative 0.67, and then this one would be negative 0.67 as well. So they're the exact same answer. Now there's a couple more that are the same, and your job is to go through and find which ones they are. So also here, remember these ones are different, so find the ones that are equal to that as well. Number 7, write each rational number as a decimal. The rules for converting any kind of fraction to a decimal is I just take the denominator and divide by the numerator. So I'm going to go, right, which will be 1, which will give me 1. I'll bring down a 0, decimal 2. So 1.2 will be your answer. Careful with the negative signs, like for example b. Just bring the negative out in front. That's not going to really affect your number too much. Number 8, write the rational number that represents by each letter. Now, there's a lot of questions like this on the PAT, and not a lot, but there are definitely questions like this. So let's pay some note to this. When you're dealing with rational numbers, you have to realize that rational numbers are all decimals and all fractions and all whole numbers as well. So these numbers here, a and b, most likely are going to be either a decimal or some kind of a fraction. So what you just need to do is find out how many jumps between the whole numbers. So if I go from negative 7 to negative 8, I go 1 jump, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that every jump is a tenth. So if I look, I go 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, 7.98. So A is negative 7.9. Now these ones here already have a decimal point, so negative 15.3 and negative 15.4. So let's just see what the jumps are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's another, that's easier. So now it goes negative 15.31, negative 15.32, and so on until you get to your numbers. Again, the hardest part for all these kind of questions is exactly finding out what the increments are every time. And I'll show you some more when we get to questions up there. Okay, so moving along. Number 10, write the rational number represented by each on the number line again. These are fractions this time. So now I need to look for jumps again. So this would be 1, 2, 3, 4. So there's 4 equal spots, and every jump will be one of them. So 1/4, 2/4, 3/4, 4/4, or the whole. So for F, I'm going to get negative 10 and 1, 2, 3/4. So we'll go to the next sheet now. So starting on the next page, we're going to look at the targets right away. You need to be able to solve word problems using fractions, decimals, integers. You need to be able to represent fractions, decimals, and integers on a number line. And you need to be able to compare values of fractions, decimals, and integers. And you need to put order, you'd be able to order fractions, decimal, integers from greatest to the smallest. So that is what our targets are for this worksheet, or this side. When you're dealing with word problems, look for certain keywords. Words like of means multiply. The word like difference means subtract. So in this situation, the thermostat is set at negative 18. That's your starting point. It cools down, so that's a drop, and then rises, and that's an addition. So just know for some of these key words, cool down would mean you're subtracting something, and a rise would mean you're adding something. So your job is to kind of figure some of that out. I don't want to give you all those answers. 14, write 3 rational numbers between each pair. You can't compare things, well you can, but the easiest thing is when you're dealing with rational numbers is you compare the same thing. What I mean by that is here you're comparing fractions with the same denominator. Here you are not. It will make it much more difficult. So make them the same denominator. Make them both 8, and then it's easier to compare. Here you're dealing with decimals and fractions. Choose one. Make them both fractions, make them both decimals. Either way, They need to be the same in order to compare them and to be able to write numbers in between them. So let's just pick one. Pick B. Clear this out. And we want to write three rational numbers between these two guys. So let's make this a common denominator of 10. That makes sense. We can just double this one. So that's going to be 17 over 10, which is almost 2. So let's put 0 here. This will be 1. This will be 2. 17 over 10 will be here. Right there on the number line. This, when I double it, I'm going to get negative 22 over 5, which is about negative 4 2/5. So this is 1, 0, 1, 2, 3, 4, and that's about there. Negative 22. Sorry. That should be negative 22 over 10, which is negative 2 2/10, which is better because that's over here then. Okay, so get rid of that. So now we want to put three numbers that are in between there, and they need to be rational numbers. You can choose any number from here. So I would keep it in the same denominators. So if it's minus 22 over 10, and you have to go all the way to 17 over 10, any number, minus 21 over 10, minus 20 over 10, minus 19 over 10, all the way up to like plus 15 over 10, plus 16 over 10, and so on, will work for this question. So make it easy. Don't make it more challenging than it needs to be, and then you should be fine. When you're looking at questions like, let's do E, 0.5 is 1 over 2. So make the same common denominators. So times 3, and I would compare 1 over 6 and 3 over 6. Now you want to put three numbers in between there. So how do you get three numbers in between there? Because we know that 2 over 6 is between there, but it's a lot more challenging to get three rational numbers in between there. So what I would do is I would take these denominators and I'd make them bigger. Now let's make them really big so that we have a lot of room. So let's go 18. So times 3 times 3, I'm going to get 3 over 18. Times 3 times 3, I'm going to get 9 over 18. Not that big, but big enough. Now I have 4 over 18, 5 over 18, 6 over 18, 7 over 18, and 8 over 18, and so on. So the bigger the denominators get, the fractions are the same, they're equivalent. I can easily put rational numbers in between there, but just by changing the denominators. Okay, so hopefully that helps. All of these I would highly recommend converting to either fractions or decimals. Converting this to an improper fraction. You don't really want to deal with mixed numbers ever, actually. I don't like dealing with mixed numbers. And then make sure you sketch them on a number line as well, because it's quite important that we are putting our work on number lines to represent our knowledge. And for the last little bit here, just for these ones, make sure you're always using common denominators. When you have common denominators, then it makes it a lot easier to compare numbers. Then once the denominators are the same, we just can compare the numerators to see which one's greater, or less than, or equal to. So hopefully that helps you on this worksheet.